Let me just show up my face quickly. Okay. All right. So, how have you been since
Okay.
yesterday?
Well, okay. Well, I had some classes and stuff, but this is the normal stuff. Um, so yeah, I'm glad to see that that friend of Victory actually is interested in joining. I think that is a very good sign. Let me just send Victory a message.
Okay, sure. I'll turn off my video. Okay.
For me too.
All right. So, okay.
Oh, yes, Victory.
Hi, Victory. How have you been? Hello.
Hello, Vic.
Just say hi.
Hello, hi.
Okay.
Hi, Shinian. Hello, sir.
Hello. Hi.
Sorry.
Hi.
How are you?
Good. Good. Good.
Good.
Yeah.
Sorry,
All right.
I'm using my desktop so I can
Okay.
switch
Sure.
on
Sure. Sure.
camera.
No worries. Yeah.
Um,
So, I'm turning this off. Updates. You like to start?
yes.
Okay. Yeah. Go ahead.
So, let me just share my screen. Screen one, yes. Mm, all right. Um, can you see my screen?
Yes. Yes.
All right. So there's a bit of a struggle, but I think it's under control. Maybe I'll just show you the logic a little bit. So I'm trying to test for the publisher nodes to sort of first I wanted to define each node um, as a both a server and a client from a socket perspective. So the idea is at the publish function, there's some sort of server operation going on, and at the subscribe function, there's also there's a receive, which is a client rather, a client level interaction going on. So I had to first create some test servers here, and the idea behind the basic server client is, you have a host, you have a port, and then let me just close this too. You have two consoles open. So say I run the server, right, and then I run the client. Oh, sorry, yeah. In different console, yeah. So if you noticed, I'm getting the client is receiving. It's almost like the server is sort of listening for a response. And the idea is to integrate this into our system such that the host is is our ID, and then the port. I'm thinking about using a universal port, which is that.
Okay.
Just
That's
for
fine.
simplicity for now, yeah. Yeah. So the idea is from a published perspective, first with the okay, let me just show you where. So first I try to create random data with this IP range, with this, subnet basically. And then, for that in range M, or should I say for the publisher, just generate, in this case, four IP addresses. So if I should run this, I should see that. Yeah, so you basically send the publishers with the IP, the channel, and the message. Something similar with with the subscribers. You have the IP and the channel they want to subscribe to. In our case, I used two channels between 0 and 2. Channel between 0 and 2. That's 3 channels. Sorry. And on from the matter perspective, the idea is when a pub request is received, I want to basically get the ID and bind it to port, and basically say, successfully first show it was successful, as well as receive the data that has been published, or that's been sent rather, on from the node. And so the idea will be to, like, now print out the data received and then perform the matching process based on what was there previously. But at the moment, I keep getting this error, and the most reasonable explanation is the computer does not recognize the IP range. So I have to find a way to make the computer basically know about this. It knows about the local host, the 127.0.0.1, but it doesn't know any other one. I've tried, fake data. This is more or less real data, and it's still not working, but I'm going to figure it out. But in general, that's sort of the flow, the same stuff with the subscribe, but instead of subscribe having, the send function, it's almost like the subscribe has a receive function, that such that when the match occurs or when the match happens, the send response sends it back. So in this case, the send response function will contain the server, or would I say will act as a server, and the handle response here will act as a client. So it's sort of interrelated. But also I'm trying to see, I feel like there's an easier way to actually go about all of this. I might have gone about it the more difficult way. I'll just show you an example. If I say, let me try to run this. Um, A equals, let's say nodes. All right. And B equals nodes. And if I say A equals B, it's false. So the idea is for each iteration, they are not the same. So in this, simulation sort of environment, there has to be an easier way to sort of iterate this as just, or should I say, visualize each of these components individually to say, okay, show me A with the certain variables, show me B with the certain variables, and show me how it connects to the matchup. Basically like a visualizer and sort of interactive sort of format. Because sometimes I sort of get confused. When I say confused, I'm not 100% certain that this is always executing in an iterative function. I'm not sure if the node is handling it as a group, or I think it is and handling it as individual nodes. But the moment it goes to the matcher, and which is what it sort of gets blurry in between. The lines sort of get blurred, and that's where the confusion sort of comes in. So it might be easier to create a different approach, but I'm not really sure 100% how it's going to go yet. But I'm just trying to just make sure this works first in terms of receiving the data and making sure the connections are successful. And then once the matching is complete, then I'm going to try to make the simulation work better, or should I say flow better.
Okay.
That's the
Okay, so that's the current update, right?
yeah.
Okay, all right. So I guess is there feedback from Herman?
Yeah, I mean, I think it's great that you added the networking component to it. I think so. I think because you have IP addresses there, it's trying to connect to them, and because it's not aware of the IP, that's why you're getting that. I mean, it's physically trying now to send something to an IP address, and that's the reason why you're getting that problem, I think. It's
Okay.
not just you're not just simulating a network, you are actually, I mean, if you had two nodes starting up with different IP addresses, and this would potentially send messages to each other, so I mean, that's cool. The other comment was that example where you compared the two nodes. Just one thing that you should, I mean, it could be that when you created those two nodes, they create those two lists A and B, that they both have exactly the same information in them. So they basically have, for instance, each have 5 nodes, and the publication data you want to send is the same. All the information is the same, But when you do a comparison like that, you know, especially if it's something like a list or some data structure, sometimes you need to define, you know, equality explicitly, which means that it needs to, otherwise it just compares the pointer, the memory pointer of the two variables to each other. And if it's not the same, then it says, okay, these two things can't be the same.
Okay.
So
Just two
yeah,
instances. Of,
yes, yeah. But if your two
Okay.
instances have exactly the same information, right, for you, it could mean they are actually the same. But Python doesn't necessarily know that. You have to explicitly define equality for that specific class or something like that. So that's just something to keep in mind, which is, you know, yeah, I would suggest having a, I mean, if you really want to do something like that you have over there, I would suggest looking at defining an equality operator for that specific class that you have.
Okay.
So I guess the question, okay, so you basically implemented some networking in there. And I guess the question now is, do you gonna have a bunch of virtual hosts that each has a real IP address, or, you know, in a virtual network interface and stuff like that? Which you could do, but then I suggest, you know, you might want to have a look at something like Mininet or something like that, which allows you to set up a virtual networking environment with virtual hosts and things like that. Or the other option, which I think Shunyun alluded to yesterday, was that you have all this IP information, but you know, instead of physically, you know, making the network connection, you basically, you know, fake it, if that makes sense.
Okay.
You simulate the network packets being sent and being received.
Okay. Okay.
So yeah, and I guess yeah, I mean, in the end, we want something which is closer to what you have at the moment.
Okay.
So I guess yeah, I guess if you set it up that it works with a real network, then that is actually closer to what we want in the end. Yeah, I'm just thinking, is there a way that we can have both a simulated network and a real network with a very little amount of effort? Because that would actually be the ideal. I don't know if you
So
have any thoughts there, Shunyun.
well, yes, that's my main feedback as well. Okay,
okay.
but I guess a bit more specifically is that I mean, if you're trying to go through the actual physical internet, okay, then there are a few things you might have to consider and take care of. Okay,
Okay.
for one, the way that the code is currently being written, I think you are only sending one message and getting one message back in return, like a receipt message.
Yeah.
That's
Okay,
true.
but that's you know that's the kind of like a sequential way, and you are not going to be able to say process, you know, multiple
Okay.
incoming messages that way. Okay, usually what happens is you would have a piece of code that kind of either you know is in a loop and sort of like in a callback fashion. You know, it blocks, it waits for messages, and then it processes them.
Okay.
I mean, I'm not that familiar with the Python, you know, ecosystem. But
Okay.
I think there's probably something similar that's already doing that. You might want to look it up how they are. In Node.js, for example, JavaScript, you can write you know things pretty easily by you can connect to a new node, and you can also install a handler for incoming messages.
Okay.
Okay, so you can send a message of a particular type given identified by a string
Yeah.
and a payload. Okay, and
Okay.
then that string literally is the sort of a message identifier or the message type.
Okay.
And then you can handle that message type within a callback. Okay,
Okay.
so I am suspecting something similar in Python is needed. Okay,
Okay. So
because that's the only way you can handle multiple incoming messages, say at the matcher, right? Say at a given matcher.
Yeah.
Yeah. And
Sorry.
yes, go ahead.
So just to confirm then, the idea basically is, for example, in each node, it has a function to publish. It has a function to sort of subscribe, or should I say, make a subscription request. And then in theory, should have a function to basically process messages
Exactly, exactly.
or on
And
on that node.
right.
Okay.
And in a real physical network, the processing part typically runs in another thread, okay, or
Okay.
in separate independently. But or you have one main loop, main thread that checks, that checks for incoming message periodically.
Okay.
Okay, so that's how you do it physically. But
Okay.
in terms of having what Herman was saying, that can work both on a physical and a virtual network. I think what you need is a kind of an interface. Okay,
Okay.
you need to define an interface that can
Okay.
both send and also receive messages.
Okay.
So you can think of that interface as an abstraction, network abstraction, where everything above the interface works the same, regardless of
Okay.
whether you're running on a real physical network or actually a simulated network. You see?
Okay.
So try to think of this problem this way, that you need to define a sort of an interface layer, okay?
Okay.
Where underneath that, it's different implementation for different networks, for different types of networks or different simulator or real. But above that, the code are all the same.
Okay.
Does that make sense?
Yeah.
So it's kind of like you have to make an abstraction, an assumption about what
Okay.
goes on above the layer and beneath that.
Okay. Okay.
So an interface is like an abstract base class. It's like you would have a networking class, and it would have or an abstract class which says you must have a send function and a receive function, and your function or your classes would just then use those functions. But then you have a specific implementation of that abstract base class, which is basically the one would be a real network and the other one would be a simulated network. And then your other code. So if you want to change from a simulated network to a real network, all that you do is when you configure your system, you either use the one implementation or you use the other implementation in terms of creating an instance of an object and assigning it to the what do you call it, to the variable,
to the variables.
So
basically, like in an interface, like the literal term interface,
yes,
basically that we're like an API more or less.
Yes, yeah. In Java, it's literally called an interface. Yeah.
Oh, yeah.
I'm not sure if they call it in Python.
But it's probably the same. I noticed the very similar terminology as well.
Okay.
Yeah. All right.
So is this making sense? This high-level concept. Okay.
Yes, it does.
All right. Then the specific feedback is well, I mean, for the network, real network I already talked about, but I actually would recommend you to do a fake network layer.
Okay.
Just use a simulated network for now, because it's probably easier to debug. Okay. And also you will be able to print out and catch the behavior of the sending side and receiving side much easier. When you go into a real network, there's usually other complexity that could arise. Okay, so you want to reduce your complexity at this stage, because you really want to do is to get a proof of concept working, right?
Okay.
Okay.
All right.
So that's
fine.
So okay, so if that makes sense, regarding the virtual network layer, what happens is, again, you define an interface, okay, and nodes can send to it, send to another node, for example, identified by its ID. But then
Yeah.
what you do is you will likely append that into a message queue for the receiver node.
Yes. Yeah.
You see? I mean, it's just a simple operation of attaching, sort of find the queue for that receiver, attach to it, okay? And then
Yeah.
whenever when your main loop goes to process the message, incoming message for each node, you take out the message queue and then start to process that sequentially for each individual nodes. That's
Okay.
within the simulator. Does that make sense?
Yeah. Um, so there's a bit of basically like a queuing sort of thing where it's like they are waiting.
Right. It's kind of
each
like,
node,
yeah, it's kind of like when you execute logic for each node, you will generate new messages, right? Almost.
Okay.
Could be sent to the queues of the other nodes in the system.
Yeah.
And then
Okay.
you go to the next run where each run essentially is, you can literally treat each run as processing incoming messages from, for each node of the message queue of the message it receives.
Okay. Okay.
Okay.
So just
All right.
Yeah.
just a question for you as well, Shunyun. So one thing so there's these messaging libraries called ZeroMQ or RabbitMQ,
Right.
which which implements nice queuing and producer consumer type algorithms. Do you think it's a good idea for Victory to have a look at one of them and use it in the
Yeah, I
in
think
the
so.
Fake network?
Well,
Okay, cool.
I think the basic idea is to get the minimum, the MV, sort of the prototype, the MVP working.
Yeah.
Okay, the minimum viable product working. I think it's always important to note that it's actually very quick to just get the main flow, the main logic up and running. Okay, even if you
Yeah.
think of like a complex system as Facebook, it's really just consists of, the most basic operations are you can post a message on your own wall, right?
Yeah.
And then you can check your friend's message wall
Yeah.
and leave a message, right? And
True,
that's
yeah.
it, right? And then you
Yeah.
have the concepts of individuals' accounts, right? And
Yeah.
then you can add people as friends. That's it. That is literally, I mean, that is something any competent programmer should be able to do in a couple of weeks, right? Or even less than a week, right?
Yeah.
So, I mean, if you just drop all the user interface, all the other nitty-gritty details, all the other elements, if you really boil it down to the main path, okay, that
Okay.
is literally what Facebook does. Okay,
Mm.
so I guess what I'm trying to say is it's the same thing for any type of system. If you really think of it that way, okay, if you
Okay.
really acquire this kind of mindset to sort of observe and think, what is the most basic minimum workflow that happens in this system? Okay,
Mm.
and
Okay.
I think it helps to really have a very clear idea about what that main flow is. You see?
Mm.
And then your first primary task or goal is to implement and finish that main flow and
Okay.
forget about everything else for now.
All right.
Okay.
All right.
And there's tremendous value in that because once you get the main flow going, okay, you have already come from 0 to 1. And the rest is just continuous improvements of this main flow.
Okay. Yeah.
Okay?
True. True.
But when you already have the main flow going, and you're actually already done
Mm. All right.
with 80% of this value and function. Does that make sense?
Yeah, it does. It does. Okay. Okay.
Okay,
Um,
okay.
so from what I picture, it looks like or it looks like there has to be some form of function to generate messages on the node layer, not at the simulation layer. For example, like in this case, I think the
Oh,
message is a
right. I mean, these are all complexities, I would
yeah.
say, that should belong to the implementation of a physical network layer.
Uh,
Okay.
okay.
But right now, you should really work at the abstraction of a network layer.
Okay.
Okay. I mean, in terms of what the publish does within its function. And if you like, you can also look at the vast library. Okay. To
Yeah.
sort of copy or borrow, whatever's already there. So, the
I
concept.
will.
Because I think there is already a defined, I think there's not that many function calls. It's kind of like you have one connect, where you just connect to a node with its IP and ID, or I don't know, maybe the ID is assigned. You have a connect, you have a send, right?
Okay.
And
Yeah.
then you have a kind of a receive, right? That is kind of work passively.
Mm.
And that's the most basic thing a network layer should provide.
Okay. Makes sense. Makes sense.
Okay.
Yeah.
All right. So I think next step, I think, is to simply to change your logic to work on top of a like a logic layer, a logical network.
Yeah.
Okay. And then if you can, obviously implement the actual workings of that for a simulated network, which I don't I don't think it's that difficult to implement. It's just a bunch of message queue essentially.
Yeah. Okay.
Okay, does that
All
make
right.
sense?
Yeah. Yeah. It
Okay,
does.
all right. So I guess Herman, any feedback on that or anything like that?
I think that's a good idea. I think the having the simulated network and having the interface there, I think is a very good idea. I'm just gonna send you a link to well, maybe it's better. I'm gonna send you a link to RabbitMQ and ZeroMQ, but I don't necessarily think you should dive into and do all the tutorials and stuff. I think as Shunyun said, it's a good idea to try and think what's the simplest thing that you actually want to do. And then once you know that, you figure out which of the tools and libraries will allow you to do that in the easiest way. If that
Okay.
makes sense.
Okay.
I think a lot of times difficulties arise because we overthink and overdo and overcomplicate things.
Yeah. No, I know. Yeah, I always do that most times. It's significantly better than in the past, but still, bad habits.
Okay, no. But I mean, it takes work actually to try to simplify things. Actually,
Yeah.
Right. Simplicity is the ultimate sophistication, right? I mean, that's.
Nice.
I mean, but it does require more thinking. I think, yeah, that you have to think through exactly what you want to do, right? Exactly what's the essence that you want to achieve, and try to just strip all the other details away for now.
Okay. That's fine.
Okay,
Fine.
that makes sense.
Yeah, it does perfectly.
Okay, so any other questions, or do you think the stock points you have now?
No,
Have feedback?
I think I'm fine for now. Anizia was supposed to join in, but
Okay.
I'm not really sure what happened because his number is off.
Okay, I see.
Tried
Okay,
to
all
call
right.
him earlier this morning.
All right.
But
So try
sorry
to
about that.
invite him for tomorrow. Okay.
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 I'll
Yeah,
do that.
because I think at least having one initial contact and conversation will be helpful.
Will be very helpful. Yes.
Yeah.
Too.
And also we can sort of figure out, like, for example, he could be helping you with the physical network layer, right?
Exactly. We were actually
Because
supposed to do some work yesterday as well, but I think it got on
Oh,
late.
okay,
So
okay, all right, good. Yeah, because I think it would help if some of the implementation work can be sort of delegated or seek help for, and well, you can focus on the main logic part, right?
Yeah. Yeah. Yeah.
Maybe that's one way to divide do the division, but we have to know what's the best after talking with them.
True. True.
Okay, all right.
I actually wanted to ask as well, Professor Herman, about the other master student. I keep forgetting her
Yes,
name.
Is she joining us
Alida.
anytime?
Yeah, so
Alita,
she's
yes.
yeah, so I'm having a meeting tomorrow afternoon with her, but it's gonna be after 5, and then I'm gonna find out what her work situation is.
Okay.
As I suspect, I don't think she's gonna be able to join the 8 o'clock meeting, but I will confirm that with her tomorrow.
Okay,
No,
all right.
no, that's fine. Like anytime she's available, it's just to get some help from her as well, if possible, in terms of from a collaboration perspective. And
Right. Victor is right. Yeah, and I think you can set up your own, sync up times, and
yeah,
it
exactly.
can be maybe like twice a week, once a week, depending on what works best. But
Yeah.
do get into some kind of sync with her. Okay, and
All
all
right.
this video is recorded, so she can watch, anytime she likes. So
Okay.
also just share this. You have the list, right? You have the URL for this recording.
Yes, I do. I do.
Okay,
It's on
okay,
the
yeah.
Slack page as well.
Yeah. I mean, just save. I mean, share that with her as well. And is
Okay.
she joined into the Slack channel yet? I think maybe
I'm
Herman,
not
if you can
sure.
also do that. I
Cool,
guess to.
I'll add her as well.
Okay. Yes. Okay. All right. So I think we'll talk tomorrow then. Okay. And hopefully we
Cool.
will
Very nice.
see the network layer and also the first implementation, if possible. Okay, of the simulated network.
Yeah, definitely.
Okay. All right.
Amen.
Okay. All right. Okay. So talk to you tomorrow then. All right.
Thanks so much, Union. Thanks,
Okay.
Professor
Yeah.
Harmon.
Yeah. No worries.
Okay.
Yeah. All right. So good
Cheerio.
luck. Yeah. Bye bye.
Cheers.
Yeah. See you
Bye.
tomorrow. Bye bye.